Hello, in this video we are going to talk about artificial limbs. How and why it was first developed and used in space program, how it is used today outside of the space program. That's what we are going to talk about. Let's start with Esteban Orellana.
Origins of a space program. Humans have always looked up into the night sky and dreamed about space. In the later half of the 20th century, rockets were developed that were powerful enough to overcome the force of gravity to reach orbital velocities, paving the way for space exploration to become reality. In 1930, Nazi Germany saw the possibilities of using missiles which arched 3,500 miles per hour to reach space. After the Second World War, the United States and the Soviet Union created their own missiles program to reach space. Years later, the biggest creation was the International Space Station. This is a research laboratory in low Earth orbit. With many different partners of its design and construction, this high-flying laboratory has become a symbol of cooperation in space exploration, with former competitors now working together. The station has been continually occupied since the arrival of Expedition 1 in November of 2000.
The first artificial limb was named the Canada Arm. It was installed in the same space shuttle that mentioned my coworker Orellana, the International Space Station. It was created in Canada. Because of that, the name was Canada Arm. In 1969, Canada was invited by the NASA to participate in the Space Shuttle program. Canadian company IIIC had developed a robot to load fuel into nuclear reactors. This robot attracted NASA's attention. In 1975, NASA and the Canadian National Research Council signed a memorandum of understanding that Canada would develop and construct the shuttle remote manipulator system. In other words, the Canada Arm. This robotic arm has a length of 15 meters, a diameter of 33 centimeters, and it was composed of 16 layers of carbon fiber. This robot has the same structure of a human arm with an elbow, wrist, and fingers, except these last ones were just hooks. Now retired, is in a display at the Canada Aviation and Space Museum. The purpose of it is to connect a satellite or other things to the station, move objects, or to inspect the exterior of the shuttle for damage to the thermal protection system of the shuttle. To use it, you have to go to a special room filled with windows, so you can have a 360 view of the space and the robotic arm. It is called the cupola. In the center of this room there is the main computer that shows the displays necessary to operate the Canada Arm. On the right side of it there is a rotational hand controller to move the arm between 0 to 160 degrees. And on the left side there is a translational hand controller to move the arm up and down. Also, there are 3 screens, one for the main computer and the other 2 for different cameras. Finally, there is a manual controller that controls the camera and set the arm into different modes.
A prosthesis is a part manufactured by man with the aim of replacing the total or partial lack of a body or a member that is gone or it not works for many reasons like injuries or amputations as a consequence of a problem in the circulatory system and also because of many diseases like cancer. In the 21st century, these artificial limbs fulfill a aesthetic and functional role in a member, although its first uses date back years. Also, prostheses are used in industries for the production of cars, etc. There is evidence that proves how Egyptians made artificial extensions to allow those who lost their toes or their feet to walk normally. In the 18th and 19th centuries, the production of prostheses was very common. The data collected by researchers confirm the use of leather, wood, and natural polymers for its manufacture. In addition, the technological advances of the moment allow it to improve the rudimentary and static designs of the past. In the 20th century, it was very important to help amputees return to work. So, a French doctor called Gripoyau developed accessories that could be used as a terminal unit, such as rings, hooks, and various metallic instruments that brings the capacity to perform force and precision in jobs. Science is still working on the development of more efficient artificial arms and legs, with countries like Germany, the United States, England, France, and Japan. That is why it is currently said that we are in the era of prosthetic and smart prosthetic. The manufacture of arms, legs, and even skeletons that restore mobility and even the sensation to those who need them is no longer a simple science fiction subject. In Miami, a team of specialists has managed to develop an upper limb prosthetic system capable of restoring, to some extent, the sensation of the mechanical limb, allowing amputees to successfully grasp things as small and delicate as cookies or eggs. This work, carried by a team of specialists from the Adaptive Neural System Laboratory at Florida International University and led by Dr. Ranu Young, has the approval of the United States Food and Drug Administration, the body that has just granted an exemption for this new device to be tested on humans. The technology developed by Young and his team consists of neuronal capable prosthetic hand system. This works like a pacemaker, through a smaller electrical impulse that reach specific nerves and the arm. In fact, today thousands of experimental laboratories around the world are still working on the development of systems for the brain to directly control the operation of prosthetics.
To answer the question of who gets benefits, we can present this project from the NASA. New arms and legs. The making of artificial limbs is known in the medical world as prosthetic. This field also includes orthopedic aids such as knee and neck braces. Hirschberger wants to improve the way it's made of artificial limbs. There was a need to replace the plaster and cornstarch material used to make molds for new arms and legs and similar devices. The plaster molds were heavy, easy to break, and unfixable when they broke, and were hard to ship and store. Hirschberger asked NASA Marshall Space Flight Center in Huntsville, Alabama if they could help, and he proposed the ET. MSFC and the Lockheed Martin Company are responsible for building the Space Shuttle's external tank. The ET is covered with a foam insulation. It protects the ET from heat and keeps the liquid oxygen and liquid nitrogen inside the tank at proper cold temperatures. The ET insulation is lighter, stronger, and can be worked more easily with a machine than plaster. Also important, the foam material is less expensive to use. Hirschberger tried ET foam to make molds for fighting the artificial limbs. It works. The company was able to reduce the cost of making artificial limbs, which lowered the cost for patients. They were also able to mass produce foam blanks for making molds and began to ship to artificial limbs all over America. So, in conclusion, we can get that the real who gets benefits is human, because they can have a normal life without having different difficulties, making with these artificial limbs on a lower cost.